Audio? Yeah. Hello students, welcome to ACE Engineering Academy and ACE Online. Myself, yours Ramesh Masuna sir. Now I am going to take about compiler design, NAT and MSQ question solving series as a part of GATE 2026 core booster series. When it comes to the syllabus of compiler design, we have 5 chapters called lexical analysis, parsing, syntax directed translation, intermediate code generation and code optimization. And these five phases are called the front end of the compiler. These 5 phases are called front end of the compiler. And the back end part is consisting of target code generation and machine dependent code optimization. That is not part of the syllabus of compiler design. Actually, the target code generation and machine dependent code optimization is based on the computer architecture that you might have studied in COA subject. Now, these are the 5 chapters. When it comes to the weightage, here what extent is possible in a single slide I have shown you from 2025 to 2018. When you see all these sets of papers, an average we are going to get 6 marks from the subject. And it is a small subject and where you can expect 6 marks. And this is one of the best subject. And these 6 marks also I told you in my live sessions, physical classes and even during the recorded lectures, I told you where you have to focus for these 6 marks and 99% that is guarantee of those 6 marks. And now we'll go ahead with one by one all the questions of NAT and MSQs. We'll start with the first chapter. First chapter, you can expect questions on theoretical based questions on compiler phase input and outputs and match the following kind of questions, and you will be given a program snippet and asked to find the tokens for the program. Suppose this is a program snippet is given and asked to find how many tokens, number of tokens in the above program. So how many tokens? Now 1, 2, 3, 4, 5, 6, 7, 8 and 10 is 9. It is 10, 11 and it is 12, 13, 14, 15 and whatever it is there in the double quotes is called string constant. It is 16, 17, 18, 19 and 20. So the number of tokens in the above program segment is 20 tokens. There are totally 20 tokens in the program. And this is one kind of question. And what is expected questions from this chapter? The expected type of questions are on Lex tool and one more is lexical errors. So far questions are not asked on Lex tool and lexical errors. Scope is there for asking questions on Lex tool and lexical errors. Okay, fine. Now coming to the second chapter, we call parsing. In the parsing, we have context free grammars, and the type of context free grammars based on number of derivations are ambiguous and unambiguous. If a grammar is ambiguous, it is not suitable for the parsing approaches, so we have to go for modifying the grammar. So but for modifying ambiguous grammar into unambiguous, we don't have any parsing, we don't have any algorithm for the conversion. So we have to go with the trial and error method, or else we redefine the precedence and associativity. Based on precedence and associativity, so far questions were asked and almost 6 times asked in the previous GATE, and here you can see one of this kind, and all the 6 times it is multiple choice questions only. If you can expect multiple selection questions on the precedence and associativity, how question could be. Okay, this is one of the kind of question you can answer it. Now grammar is given, and based on the grammar you decide what kind of okay, here what are the kind of question given the following expressions, and here ask to find which of the following is true, and E is the starting non-terminal, and with the starting non-terminal we have 2 operators star and plus, and whatever the operators that are defined with the same non-terminal E are having equal precedence, and these are represented with a starting non-terminal. And if you have to construct a parse tree using this grammar, and the operator star and plus should always appears on the top of the tree. Why? Because the tree should start with a starting non-terminal. If it is appearing on the top of the tree, it is going to be evaluated last. So it is evaluated last means these two having lower precedence, and minus is going to have higher precedence. Now you have to check for which is a true. Star having higher precedence than plus, no, it is wrong. And minus having higher precedence than star, correct. Star and plus having same precedence, correct. Plus has lower precedence than star, wrong. So what is the correct answers? Both B and C are the correct answers for the questions. Okay, done. Oh, in between ads also coming. Very good. Enjoy. Fine. So when next comes to the CFGs based on number of input strings. CFGs based on number of input strings are recursive grammars and non-recursive grammars. And recursive grammars are left recursive, right recursive, general recursive. For defining the syntax of a programming language, we use recursive grammars, either left or right recursive, but we know the point that left recursive grammars are not suitable for top-down parsers. If a grammar is not suitable for the parsing approach chosen, we have to go for modification of the grammar. So in that modification, we have discussed elimination of direct left recursion, indirect left recursion, left factoring. So far question is not asked on left factoring, it is an expected topic. Questions were asked on left recursion elimination, direct and indirect, both were asked. So this is one of such kind of question. Next, so which of the following grammars are left recursive? Which grammars are left recursive? Just take a minute of time and try to understand and answer the question, right? Yeah. Look at this question, try to understand and answer it. Yeah. Here, which of the following grammar are left recursive? A is deriving B, or A or CBD, and see this B is deriving C, and look at this C is deriving A, again this A is deriving A, right? So A deriving B means we have recursion in this one. A deriving B, B deriving C, C deriving A, again A derives B. So we have in option A, we have a left recursion. So, but it is not direct left recursion, it is called indirect left recursion. The question is which of the following is having left recursion? So option A is left recursive. Very good. Sharath, Peter Parker, Thiru, nice. And here A deriving B and B deriving A. So again indirect left recursion is there. Very good Anvesh and very good Satvik. So B is also correct answer, because in A and B we have a indirect left recursion, right? And this is direct left recursion, Q deriving Q, it is a direct left recursion. So C is also correct answer. In D, you just check it out. S is not deriving left, leftmost symbol is not the non-terminals, it is a terminal open parenthesis, it is a terminal X. But L is deriving non-terminal S, but S is not deriving non-terminal L. So S to L to S, S to L, no left recursion is there. And L dash is deriving S, but S is deriving some terminals, no left recursion is there. So because no left recursion, D is wrong, because question is about free from left recursion, because question is about free from left recursion. So correct answer is A, B, C are the correct answers. And one topic, left factoring modification, on that questions were not asked. So it is possible to be asked questions on that. Next, we move to parsing approaches. We have a top-down parsing approaches, bottom-up parsing approaches. Some theory questions were asked. Which of the following is top-down, bottom-up? Based on the techniques. Okay, based on what techniques comes under top-down, what techniques comes under bottom-up, that you can focus on it. And in the top-down parsers, we have a questions on predictive parsers that we have discussed. Okay, we have questions on predictive parsers. And how questions were asked on predictive parsers? They have given a table, a partially filled table, and some entries are left blank and are numbered with some number, and asked to find what should be there in the numbered cells. These kind of questions were asked. And what is expected? It is expected to be something new type of questions, as a numerical answer type question, or else multiple selection questions. Here you can see a question. For the grammar have given in the predictive parse table, the cell having the multiple entries is, which cell is having multiple entries, which entry is defined multiply. Okay, just try to understand and answer it. Take a minute of time. Take a minute of time and try to understand and answer it. In predictive parsing table, the cell having multiple entries is. So what option A given? A row, X column. Now A row asking X column. What you can see in the A row X column? A row can have A productions. A tends to X, you write in the A row X column, there is no issue in it. A tends to BCY, you write in the first of BCY. What is the first of BCY? First of BCY is first of B. First of B is both X and Y. So means A tends to BCY, you write in the X column and Y column. A tends to, A derives B, capital C and small y. A derives capital B, small c, small y. So means A row X column, A row X column. What you can see? A tends to X, A tends to BCY. Very good. Jila Sharath, Peter Parker, Devara, Satvika. So A is correct, but question is about multiple selection questions. Na? More than one option might be correct, and you have to check what other options are also correct. Okay, Isha, very good. Isha, very good. And second option is M of 0 Y column. Okay, 0 and Y column it is same. And in 0 Y column we write C tends to small y capital A. Why? Because C tends to YA, you write in the first of YA column. And C tends to epsilon, you write in the follow of C column. Follow of C column. Right? Now what is a follow of C? Follow of C, here you can see Y. Follow of C is Y. Right? Now in the Y column also we write. So means C tends to epsilon also you write in the Y column. This is also entry defined with multiple productions. So A is correct, B is correct, and just check for C. C is about B row. B row Y column, B row X column. B row Y column we write B tends to YB, and B row X column we write B tends to X. Any entries defined with multiple productions? No. Okay, so correct answer for this question is A and B. Fine. So who answered correctly? Crimson, Muffin, Isha, Devara, okay, Devara and something Peter Parker, and some of you are excellent. So I can definitely happy to say you are done good job. So option C and option D are incorrect, A and B are correct. Okay, chalo, I am expecting quick answers from you. Okay, so what you said, because C crimson on, fine, perfect, muffin, done. So next, when it comes to the bottom-up parser approaches, some theory questions were asked, and along with that, questions were asked on shift-reduce parser, and most expected is viable prefixes. Here is some theory question for you. Which of the following is false? Which of the following is false? Brute force technique is SR parser. SR parser means shift reduce parser, or bottom up parsers also called shift reduce parsers. Brute force technique is a top down parsers. SR parser is wrong. Correct? Is it done? Now, operator precedence parser is a top down parser, but operator precedence is a bottom up parser. It is also false. Recursive descent parser is a bottom up parser. No, it is a top down parser. It is also false. Operator precedence parser is a SR parser. True, because question is about false. Option D is wrong answer. A, B, C are the correct answers for the question. Okay, some theory questions like this also possible to be asked. Peter Parker, that's quick, very good. Next, so crimson muffin, you're also very good. And here I have seen, I was keep on telling many times, this time you can expect a questions on viable prefixes. And viable prefixes is one of the important topic this year. I am expecting this year one numerical question on topic of viable prefixes. Okay, done. The question is, consider the following grammar. And question is, find the number of viable prefixes for the input string AACBB. Number of viable prefixes for the input string AACBB. Now, do you remember what is viable prefix? Tell me. Do you remember what is viable prefix? What is a viable prefix? Those are called prefixes of a right sentential form that can appear in the stack of a shift reduce parser. Before I finish my explanation, just try to find it and give the answer in the chat box at the earliest. Wow, that's so quick. Sharath, 4 viable prefixes. It might be, hopefully it is wrong. Satvik, 4 viable prefixes. How? Satvik? Chalo. What are the viable prefixes? The prefixes of a right sentential form that can appear in the stack of a shift reduce parser. Okay. How do you do this? We write stack and input buffer and what actions you are performing to derive that input sentence, you write it. Okay, Peter Parker, prefixes in a stack. Perfect, Peter Parker. But how many? Question is about how many. Now, initially stack do have nothing. Input string is AACBB and with a $. Initially no handles. Virtual verdict 4. So, all of them are giving 4. Anvesh 3, Tiruchannel 3, why? Seshu Puvala 7. I think 7 is the right answer. So, because no handle, it has to perform a shift action. $ACBB, $. A is not a handle. So, again we have to perform a shift. $AACBB, $. And any more handle? No. Any handles? No. Again shift it. $AACBB, $. Now handle is found. What is that handle? Now what is the handle? Handle is a C. Now C is a handle. it is matching with the production S derives C. Whenever a handle is found, it has to perform the reduction. Okay, good. Sharon, Isha, 8 given. Okay. Now $AA, that C should be replaced with S, and B dollar. Now again we have to perform a shift. When you perform a shift, $AAS and B is shifted and B dollar. Now when you scan the stack, we can find there is a handle that is matching with RHS of a production. S derives ASB. Whenever a handle is found, it has to prune the handle. Prune the handle means replace RHS with LHS. $ASB dollar. No handle, then again it has to perform a shift. So $ASB dollar. Now it can find a handle. Good, Peter Parker, Isha. And ASB is a handle, that is S is deriving ASB, and dollar, that is replaced with S dollar. Any more handles? No. And what is left in the input? Nothing, means total input is shifted into the stack, and stack left with only starting non-terminal, means reduction of input happened with S. Then parser announces successful completion of a parsing, that is accepted. Now you understand how many viable prefixes are there. These are called prefixes of a right sentential form that can appear on the stack of a shift reduce parser. What is there? A there, 1, okay, 1, 2, 3, 4, this is 5, 6, 7 and 8. So how many prefixes are there? These are 8 prefixes. The total 8 prefixes. So who have answered 8? Harsha, Muffin, Peter Parker, Isha and Sharon. Nice. Good in number. Your answers are accepted. Fine. Good. So how many viable prefixes? 8. Anything is repeated? Nothing is repeated. These are viable prefixes. Then questions were asked on LR parsing approaches. Next is questions on LR parsing approaches. In LR parsing approaches, we have a family of LR parsers. Some theory questions are possible to be asked on LR parsers theory, and in that, so far we have seen questions on LR of 0 items. Most expected is how many items in LR of 1 states. So far asked is LR of 0 states, how many items are there. But LR of 1 is the most expected in that family of LR parsers. And this is one of the question. Consider the augmented grammar as the set of terminals, and these are the grammar with augmented production S dash to S. If I0 is a set of 2 items, S dash derives S dot and S derives S dot R, S dash derives S dot and S derives S dot plus R. This is I0 is the closure of I0 is a set of 2 LR of 0 items. These are this one. Then go to of closure of I0. In this I0, any more items are possible to be added? No, because here augmented production dot reaches to the end. Here after dot we have a terminal. No more items are to be added. So closure of I0 is I0 itself. Then go to of I0 on input plus. On input plus, what is a move? Moves. S is deriving S plus dot R. S is deriving S plus dot R. So dot R is the non-terminal. So dot R means R productions we have to use. Dot R star P, R tends to dot P. Because dot P there, we have to add P productions. P derives dot open S close and P derives dot ID. These are the items possible. Now this is assuming I1. So means when we move dot 1 position right from 0th state on input plus, we are getting some state I1. Now the question is, then I1 state contains exactly dash items. How many items? 1, 2, 3, 4, 5. So 5 items are possible. This kind of, wow, this kind of questions were asked in the previous gate, and but questions are on LR of 0 states and items. So possible to be expected on LR of 1 states and items, right? Okay, Peter, Parker, Sharon, Sujan, Ashrita, Siddhartha, Teja, Isha, Sharath, Muffin, Satvik, Sesha, and good in number. These people have answered correctly. I will definitely appreciate you all. Fine. Chalo. And next is type of the grammars, also one of the important questions. So you are given this question, the grammar, it is mentioned, and it is mentioned the grammar is LR of 0, SLR of 1, LALR of 1, LR of 1. What type of grammar it is? We can say a grammar is an in so and so type of LR if there is no conflicting states. Means if there is no shift reduce, no reduce, then we can say the grammar is belongs to one of the LR grammars. Means it is LR of 0 or SLR of 1 or LALR of 1 or LR of 1. Okay. Here because it is MSQ, if it is LR of 0, then answer is ABCD. If it is SLR of 1, it is BCD. If it is LALR of 1, CD. If it is LR of 1, only D, right? So the point is every LR of 0 grammar definitely SLR of 1, LALR of 1, LR of 1. So question can be asked as MSQ also. Okay. So MSQ kind of questions possible to be asked, and focus on it. So far not asked, but scope is there. More scope is there for asking such questions. So how do you solve this question? First we find LR of 0. LR of 0. How do you do this? Augmented productions, augmented grammar, S dash tends to dot S. Dot S means S productions, dot capital A small a, S tends to dot small b capital A small c, S tends to dot DC, S tends to dot BDA, because dot A is there, A production, A tends to dot D. Now when you move dot one position to the right with respect to S, one item, with respect to A, one item, with respect to B, two items are possible. Look at S tends to B dot capital A small c, S tends to B dot small d small a, because dot capital A production, A tends to dot D. Okay. Do you have any conflicting states here? No. And but you can see, okay, you can see with respect to D, we have two possibilities. That is S is deriving D dot C and A is deriving D dot. Now here we can call it is a conflict in LR of 0. It is called shift reduce conflict in LR of 0. Why? This is a reduction and this is a shift. Now it is SR conflict. It is SR conflict in LR of 0. So it is not LR of 0. Option A is wrong. Just check for SLR of 1. For SLR of 1, what we have to do? This is to be filled in the follow terminals of A. Now what is a follow of A? Follow of A is A and C. Now C is a common terminal. So it is a SR conflict in, it is SR conflict in SLR of 1. So B is also wrong. Then we have to check for LALR of 1 and LR of 1. For LALR of 1 and LR of 1, what we have to do? We have to add look ahead symbols to LR of 0 items. We can call LR of 1 items. So for this only same thing, you just add look aheads. S dash tends to dot S comma dollar dot S for S productions. For all these 4 S productions, look at is what immediately after S possible. Dollar dot A production, what is immediately after this A? have written A tends to dot D because of this capital A, not all capital S. What is the immediate next symbol after capital A? Small a. Okay, now no conflicts. So when you move dot one position to the right, these S productions have a look at dollar and dot A production added. What is the immediate next symbol after this A, C? So anyhow, no conflicts in that. Here S tends to D dot C comma dollar, A tends to D dot comma A. Now see, this shift is on C, reduction is on A. Shift is on C, reduction is on look ahead in the LALR of 1. So means it is not SR conflict in LALR of 1. Any possible conflicts also you can check it out. You can check for any further possible conflicts. Here with respect to A, one item possible. When one item there in the state, no conflicting entries are possible. When more than one items in that state, you may expect. So that's why I'll be writing only those states. S is deriving BD dot A comma dollar and A is deriving D dot comma C. Now here you look at, this is shift with respect to A and this is reduced is on C. It is also not SR conflict in LALR of 1. So in LALR of 1 it is not SR conflict, but these are SR conflicts in LR of 0 and SLR of 1, so that LR of 0, SLR of 1 is wrong, it is LALR of 1. If it is LALR of 1, definitely it is called LR of 1. Why? Because LR of 1 is a superset of LALR of 1. So every LALR of 1 grammar is LR of 1. So answer for the question is both options C and D. Okay, these kind of questions also possible to be expected. Okay, I hope you have done this, most of you, but may not be this much quick, but do practice more to make the problem simpler and sweeter and shorter, so that you can answer very quickly. Okay, done. Next is some theory questions. Here is one theory question for you. Here is one theory question. Which of the following statements are true? CLR of 1 parser is more powerful than LALR. So before me answering the questions, I suggest you to solve and answer it. CLR of 1 parser is more powerful than LALR. CLR means LR of 1 is more powerful than LALR. True. Perfect. The number of states in CLR of 1 is always more. Is it guaranteedly more? No, it is not necessarily be more. False. If the grammar is LL of 1, then it is always LR of 1. This is a true statement. Every LL of 1 is definitely be LR of 1. And number of states in LALR of 1 is always same as SLR of 1. So we know that number of states in SLR of 1 and LALR of 1 are always same. So it is also a true statement. Question is about true statements. So answer is A, C and D are the correct options for the question. Okay. Fine, that's quick. Oh, I have seen some students answered. Muffin, you selected B. B is a false statement, Muffin. And so Anvesh, Sharath, Anvesh good, ACD is correct. And Sharath, even B is also, even C is also correct. Sorry, D is also correct, Sharath. Fine. Okay. Chalo. Next question. It is somewhat interesting and interesting question. Just look into it and understand what will be the answer for the question. Consider the parsing tables of SLR of 1 and LALR of 1 for a context-free grammar, which of the following should be equal in both the tables? It is about SLR of 1 and LALR of 1. What should be equal? So we know that in SLR of 1 and LALR of 1, number of states are equal. Number of states are equal, but that is not mentioned here. Go to part. So because states are same, go to part definitely be same. And reduce entries, is it same or different? In SLR of 1, reduces we fill in all follow terminals. Sorry. Yeah. In SLR of 1, we fill the reduces in all follow terminals. In LALR of 1, we fill the reduces entry in all the look ahead terminals. All the look ahead terminals. So because it is not all follow terminals, in LALR of 1, not all follow terminals, only in the look ahead terminals. So because reduces entries are different in SLR of 1 and LALR of 1, but it is saying equal, so reduce are different. When reduce are different, some blank entries definitely made to be different, so error entries also different. Because go to part is same, means with respect to non-terminals it is same, and with respect to terminals also same, because number of states are same. When number of states are same, moves with respect to non-terminals are same, we call go to part is same, moves with respect to terminals are same, shifts are same. And but reductions here in follow, here in look aheads. So reduce are different means error entries also different. Got it? So what is the correct answer for this question? A and D. Sharon Sujan, that's quick. That's fine. I am expecting everyone should participate in the discussion. Next question is on, next after this questions you can expect on syntax directed translations. We have syntax directed definition where SDD is given, input is given, asked to find output for the input based on the semantic rules. This is one kind of question recently also asked in 22, 23 and 25 also it is asked. And next questions on type of SDD. SDD is of two types, S attributed and L attributed. We can call SDDs S attributed if it uses only synthesized attributes, no inherited attributes. L attributed is required to have synthesized and or inherited attributes, but the condition on inherited attribute should be evaluated from left to right, not from right to left. Means it should be evaluated from left sibling but not from the right siblings. Keep in mind that point. Based on that you can solve the questions. Previously also asked something around 3 times question asked, and this is also one of the expected question. Which of the following statements is are correct? To check for this option A, Q derives EF where Q parent is getting its value from E and F, so we can call I is synthesized attribute because it is synthesized attributes. We can call it is S attributed, and we know that every S attributed is also L attributed. Question is about is R correct? Okay, fine, A is the correct answer. And B, R tends to AB, BI, this one you are getting from RI, parent, fine, I is inherited. If it is inherited, it is not S, okay, it is anyhow neither S is given, fine. And is it L attributed? If it is to be L attributed, should be defined from parent and or left siblings, but here it is parent, it is okay, this rule is okay. And AI means this one, getting its value from BI means right siblings, so getting value from right sibling is not allowed, so it is not L attributed. So not S, not L, perfect, this is also correct statement, B is also correct statement. Okay, very good, that's quick. by Peter Parker, Sharon Sujan. Nice. Option C, look at S tends to, A tends to B, C, D, C deriving this one, getting from A, parent, and B, left sibling. Okay, this is perfect. S is inherited and getting its value from parent and left sibling, and CS you are getting from DS, means C also getting from DS, but it is getting from right sibling. Getting it from right sibling says it is not L attributed. It is not an L attributed grammar. Perfect. Now it is not L attributed grammar because this is violating. Done. So A correct, B correct, C correct so far, and check for D. Okay, Peter Parker, you are good. Right, Satvik, and C is also correct now, Satvik. And L attributed SDTs are evaluated in bottom up fashion, but L attributed are not evaluating from bottom because L attributed definitions are deriving its attributes in the case of inherited from parent and left sibling. It is parent and left sibling means top to bottom or right to left, left to right, but not right to left. But it is mentioned bottom up, bottom to top. Bottom to top is required by synthesized attributed. So L attributed SDTs are evaluated in bottom up. So in L attributed, if all attributes are synthesized attributes, bottom up okay. As the values of the parent nodes depend upon the values of the child nodes. This is only in the case of synthesized attributes, but here not talked about inherited attributes. If it is in the case of inherited attributes, this bottom up evaluation is not allowed, not possible. Why? Because L attributed definition means it can allow inherited attributes also. If inherited attribute is there, can it be possible to derive from bottom up traversal? No. So D is wrong. So what is the correct answers? A, B, C are the correct answers. Okay. B option. So okay, Sharath asking me to explain B option. What is B option? Look, R derives AB, B getting its value from Ri, parent, okay, allowed, inherit attribute, and A deriving its value from B, means A is getting from right sibling, but if it is L attributed, it should not be from right sibling, it should be from left sibling. That's why it is not S, not L, okay, not S, not L. It is also mentioned neither S nor L, so B is the correct answer, okay. Okay, Sharath, done. And also you can expect questions on translation scheme, and this is one of such kind of question. If this is an input given and what this translation prints, you have to find the answer in the numerical answer type question. How do you do this? S is deriving X, Y and C, and it is to print 1. Next we wanted B from Y. To get B from Y, with Y we don't have a B, Y we don't have a B, so what Y should do? Epsilon, so it should print 4. With X now we have to get B and C, so we go with YB production. So C we got, B we got, and YB production has a semantic rule, print 3, and Y should derive C, deriving Y, C with Y is print 5. Now what is to print? 5, 3, 4, 1. So 5, 3, 4, 1 is the answer for the question. It is a numerical answer type question. Okay, fine. Sharath, thank you. Wow, very good. Simple rule, Peter Parker, perfect. Done. And next we go with intermediate code generation. In the intermediate code generation, we have a questions on minimum number of variables in TAC, minimum number of variables in SSA code. There you have to focus. Along with that, questions were asked on number of nodes and edges related to DAC. Okay, number of nodes and edges related to DAC. So here is a question asked to find how many nodes, number of nodes in the DAC. How do you do this? First we create a node for C, node for D, node for plus, adjacent nodes are C and D, name this node as A. Now node for A already there, node for D already there, now node for plus, adjacent nodes are A and D, name the node as E. Node for C already there, node for D already there, plus with C and D also there, this is D. Now we can call first one and third one are the common sub expressions. Because common sub expressions, those are represented with same part of the tree. So how many nodes are there? 4 nodes are there, right? That's perfect. Done. That is a 13th question. Now when it comes to the 14th question, along with that you may expect a questions on control flow graphs. So far questions were asked number of nodes, number of edges, number of basic blocks, number of instructions in the largest basic block. This kind of questions were asked. So still there is a lot of scope of asking such kind of numerical answer type questions on control flow graphs. Okay. Here what to find? The question is find the number of basic blocks. I gave you some simple rule for finding the number of basic blocks. The number of basic blocks are equals to number of leaders. Now what is a leader? First statement of the program is a leader, right? And target of any go to statement is a leader. Go to label 4. Where is the label 4? Here. It is also leader. Its next statement is also leader. Go to label 5. Where is label 5? Label 5 is a leader. Its next statement is also a leader. Fine, that is also leader. Go to label 12. Go to label 12. Okay, label 2, sorry. Label 2 is a leader. Its immediate next statement is a leader. Any more? First statement is a leader. Go to label 4. Label 4 is a leader. Its next statement is a leader. Label 5 is a leader. Its next statement is a leader. And go to label 2. Label 2 means 2 is a leader and its next statement is a leader. So how many leaders are there? 1, 2, 3, 4, 5. 5 leaders. So 5 basic blocks are possible. Okay. There are 5 basic blocks in the program. Done. And next is some theory questions on optimization techniques. That is, a basic block is a sequence of instructions where control enters the sequence at the beginning and exits at the end. It is a true statement, correct? Because question is true statement. Live variable analysis can be used for dead code elimination. Yes, this is also true. Available expressions can be used for common sub expressions. True. X equal 4 into 5 is replaced with x equal 20 is called constant folding. Is called constant folding. But it is mentioned strength reduction, it is false. So correct answer is A, B and C. Right. So good questions and good answers from many of you like Peter Parker, Sharon, right, and many others. Fine, I am taking only few names, but many others are giving the good answers. And one important thing is questions are possible to be asked on live variables. Questions are possible to be asked on live variables. Now look at, consider the following basic block. This is a basic block. And what will be the variables that will be live at the beginning of the block? So at this point, which variables are live? We can call in block, in of this block, in variables. What are the in variables? The variables that are live incoming into the block B, means from that point, incoming point of the block B to the exit, we have to see which variables are used before redefinition. So here B is used before redefining, A is used but after redefining, and C is using after redefinition, E is using after redefinition, and D is using before redefinition, means first used, later it is defined. So which variables are live? B and D, that is option B and option D. But A and C are not live because A and C are used, but usage is after definition. But live is nothing but first use, later define. So which options are correct? Both B and D are correct answers for the questions. Okay, this is all about the topics from where questions are possible to be asked. And when I was taking one live session for the online live batches, I have listed all the key topics where you have to get a questions. And I just thought of showing you this slide. Just I will move aside from the screen so that you can take a screenshot of it if possible, and it will be helpful for you for your preparation. And whatever I have written in the blue color are expected topics, and in yellow color whatever I have written are the topics from where questions were asked. Okay, you can take a snapshot of it. So totally 33 topics I have written, and in that blue color whatever I have written are the topics from where you can expect questions, expected type of questions. Okay, and in that most expected is viable prefixes. Fine. So with this I am going to end up my session of this booster series, and I would like to inform you all to write Pre-GATE 2026, which is going to be conducted by ACE Engineering Academy and ACE Online on 8th January 2026. Okay, in 8th January 2026. For CSIT it is morning 10:30, and to register it you need to scan the QR code for registering that mock gate, and the questions are almost on par with the real gate examination, so that you can check your rank, your marks with respect to our mock exam. That will be definitely boost your confidence. And also we are going to start a revision series from 10th of January. So from 10th of January, GATE 2026 revision series. Every subject we are revising in a short and crispy manner, something around 5 to 6 hours of a lecture we are going to conducting, means morning 7 to 1:30. It is depending on the subject. So number of hours are varying, but the total revision is going to be done for each subject, and that revision series will be definitely helpful for you in recollecting all the concepts in a short duration of time. And we are not just revising this topic, we are revising the topic with respect to questions, so that revision will be over, kind of questions possible to be asked, that is also going to be done in the revision series. It is damn sure it is helpful for you for your preparation. Okay, and to register for revision series, just scan the QR code and you can register for it and you can attend it. And definitely I can say you one thing, जीत और हार तो परिणाम है, कोशिश करना हमारा काम है, कोशिश करते ही रहिए. Forget about winning or losing, just आप खुद का कोशिश करो, अपने ऊपर भरोसा रख, मेहनत करो, अब definitely आपको अच्छा रैंक आएगा. So I can say you only one thing, do your best. And with this I am going to end up the session by saying a big thank you to one and all, and listening to me patiently, right? Patiently, and hope this session is helpful for you, and recommend this session to your friends also to watch. And definitely this is a booster series for your confidence. Wishing you good luck. Thank you.